Hi everyone, welcome back to the channel. Again, I'll start my video by saying thank you to each and every one of you who is watching my videos, who is loving my videos. So yes, thank you so much, everyone. So this is basically a second part of our video. So if you have not watched the first part, I'll put the link in the description box. So do check the first video as well. Because this is the continuity of the last video. So yeah, so in the last video, basically we had covered some basic, things like Euclid's division algorithm, some questions, a formula on LCM and HCF, and then the two numbers, and we had solved some questions. So this is our second video where I'll be talking about rational and irrational numbers. I have already talked about, whole numbers, natural numbers, integers in my first video, which I have basically talked in my last video. So please do watch my first video and the first part of this video as well. So I'll put the link in the description box for sure of both the videos. So don't forget to watch those two videos as well. Now let us start with today's topic. So basically, rational and irrational numbers. It is basically a family of real numbers. So we have real numbers, right? And in real numbers we have rational numbers. Okay. So irrational number will not come in real numbers, of course, because that is not in the family of real numbers. So yes, rational numbers come under the family of real numbers, and irrational numbers are something else. So we will be talking on both the topics, rational and irrational numbers. So let us quickly start with the topic. So this was the last question that I had asked all of you in my last video. So if you have not watched the video, if you have not answered this question till now, please solve this and let me know your answer in the comment box. All right. So today we are going to cover our second topic, which is rational numbers and irrational numbers. So let us first start with rational numbers only. Okay. So this is a very simple concept. Okay. You can understand it very, very quickly. Let us understand this. So first, before understanding anything, we should know what is this topic. Okay. How do we define it? So let us understand the definition first. So what are rational numbers? So any number, okay, any number which you can write in the form of P by Q, where P and Q both are integers and P and Q are both co-primes, okay, and the denominator, of course, cannot be equal to 0, are called nothing but rational numbers. Now, what is the meaning of co-prime? So meaning of co-prime is nothing but if you are taking two numbers, okay, and if the HCF, that is highest common factor, comes 1, that means they are co-primes. Okay, that is how you can find whether the two numbers are co-primes or not. So let us write down the definition first. So what are rational numbers? So a rational number, or we can say a number in the form of P by Q. You can say A by B, P by Q, anything you want. A number in the form of P by Q, where P and Q, okay, where P and Q are integers. And also P and Q are co-prime. Normally, some students do not write down this specific sentence that P and Q are co-primes. So that means the definition is not complete. Okay, the definition is still half. So it's very important to underline this sentence, which is P and Q are co-prime. Very, very important. Okay. And of course, Q cannot be equal to 0, right? Because if Q will be equal to 0, that will be something which is undefined, right? So I'll just highlight the important part, which is P and Q are co-prime. Okay, so this is very important to add in the definition of rational numbers. Yeah, so this is a rational number, a number in the form of P by Q, where P and Q both are integers, P and Q are co-prime, and Q is not equal to 0. You have infinitely many examples for rational numbers. Let us start with 2. Is 2 a rational number? Absolutely, it is a rational number, because 2 you can also write down as 2 upon 1. And when you write down 2 upon 1, it is absolutely in the form of P by Q, where P is 2 and Q is 1. Absolutely 2 and 1, they are co-prime, because you will be getting the HCF 1, right? Because that is the definition of co-prime. And of course, Q is not equal to 0 because 1 is not equal to 0. So yes, 2 is a rational number. You can say 1 upon 5 is a rational number. Yes, absolutely, this is a rational number. We can also say, -5 upon 4. This is also a rational number. 0, what about 0? 0 is a rational number. Yes, 0 is also a rational number, because here when you're writing 0, 0 is nothing but 0 upon 1, and it is still satisfying the definition of rational number. So therefore, this is also a rational number. And in this way, you can write basically infinitely many rational numbers. So that is why we can write a lot of examples for rational numbers. So let us write down these many only. Okay, so I hope now rational number definition is clear, co-prime clear, denominator not equal to 0, that is clear. I hope everything is clear in rational numbers. Now let us move ahead to irrational numbers. Okay, what are irrational numbers? Okay, for example, you can say that here rational and irrational are quite opposite of each other. So can we not say that just the opposite of what we had written for the definition of rational numbers? Can we not write down that any such number which cannot be written? Okay, just note this, which cannot be written in the form of, okay, in rational number we could write in the form of P by Q. Here in irrational number we cannot write down in the form of P by Q, where you can just write down the same thing, where P and Q are integers, they are co-prime, and Q is not equal to 0. The only difference that you will write down in the definition of irrational number is that a number which is, or a number which cannot be written in the form of P by Q. All right, so yes, you can write down. Let me change the color. Yes, so a number, I'm just writing in short, a number which cannot be written in the form of P by Q. Okay, where of course the same thing you can write down, where P and Q are integers, and here you can directly write down Q is not equal to 0, right? So here, what is the most important thing? The most important thing here is cannot be. This is something which is, just differentiating the definition from rational and to irrational numbers. Okay, so yeah, this is an example of irrational number. Now, how many examples do you know for irrational numbers? Again, infinitely many. Okay, so we can write down example as √2, √3, correct, √5, √7. Can we say root under 16 is irrational? No, we cannot say this. Why? Because basically when you will solve this √16, it will be 4, and 4 is a rational number. Okay, because 4 can be written in the form of P by Q. So yes, and we have a lot of examples. All right, now let me tell you a very important thing about pi. What about pi? Is pi a rational or irrational number? So many students, like they are confused that why something in pi is rational and something is irrational. So let me tell you that this pi is irrational. Okay, why is it irrational? Because the value of pi, if you will just Google, okay, if you just Google and check that what is the value of pi, you will see something like 3.14 and a lot. It will never stop. So because that value is never going to stop, which is called non-terminating repeating. Okay, we can say that non-terminating or non-repeating. So it is not going to terminate anywhere. Okay, so there is no stop at the end. So that is why we can say that pi is irrational. But when you write down the value of pi as 22 upon 7, because you know that the value of pi is also 22 upon 7, and this 22 upon 7 is a rational number. So that is why we can say that this is a rational number. So how you can say that which is rational, which is irrational, you can just simply say that pi is irrational, but the value of pi, which is 22/7, is rational. All right. Okay, so now we can move ahead with to the concept of terminating, non-terminating, non-repeating, repeating. Okay, let us understand that. So basically, how we can say by just looking at any any fraction or any rational number, whether it is going to be a terminating, non-terminating, or repeating, non-repeating. Okay, let us understand how we can do without actual division. Okay, you don't have to divide, and you will check it. Okay, after doing the division, whether you are getting a decimal in terminated form or non-terminated form, you will get the answer directly without actually doing the division. So let us understand how. For example, suppose I have a question 315/16. Okay. Now, what you have to do here, you have to just convert the denominator, or basically you have to find the prime factor of the denominator. So you know that 16 we can write down as 2 into 2 into 2 into 2, right? And which is same as 2 raised to 4. Now, there is one thing that you should note, you have to notice that if you have, okay, I'm just writing in as a note, that if you have something in the denominator, the prime factor in the form of 2 raised to m into 5 raised to n, where m and n both are positive integers. Okay, you know what are positive integers? Whatever the numbers that lies on the right side of 0. Okay, those numbers are positive integers. So where m and n are positive integers, okay, then, okay, if you can see that you are having something like this in the denominator, 2 raised to m into 5 raised to n, where m and n are positive integers, then the decimal has, or the fraction will be a terminating decimal expansion. So then the fraction has terminating decimal expansion. Terminating meaning it will stop at some point, right? Has terminating decimal expansion. Remember, if you just get confused between terminating and non-terminating, just understand the meaning of terminating. Terminating meaning it terminates at some point, right? For example, a train terminates at this particular station. So terminates meaning it gets, there is nothing after that. Okay, so it terminates, right? So that is the meaning of termination. We can say that it terminates, it gets stopped somewhere. Okay, so yes, it gets stopped somewhere. So that is the meaning of termination, terminating, terminate, whatever you want to say. So yeah, that is the meaning of terminating decimal expansion. For example, we can also say that 1.345. This is a terminating decimal. Okay, for example, let me write down that for you. This is an example for your understanding. Terminating decimal expansion. Now let us see what is non-terminating decimal expansion. So non-terminating will be something like 1.45684325198. It is not going to stop. It will go on, right? This is called something non-terminating decimal expansion. Okay, this is called non-terminating decimal expansion. Now let us understand about repeating and non-repeating. Okay. For example, suppose you have 2.33333, and this 3 is going to, it is not going to stop anywhere. This 3 will come as you will move forward, right? So that is called something non-terminating repeating. Okay. This is basically called non-terminating non-repeating. Why non-repeating? Because no digit is getting repeated. Okay, so that is why we can say non-repeating. But here you can see that this digit 3 is getting repeated, and it is not getting terminated also. So that is why non-terminating but repeating. Okay, non-terminating repeating decimal expansion. Okay, yes, decimal expansion. So I hope you have understood the meaning of terminating, non-terminating, repeating, non-repeating, everything, right? Let us understand with some example now, okay? So we had a question 315 upon 16. Now, without actual division, you have to check whether this is a terminating or non-terminating. So what method I told you? You have to just take the denominator. You have to find the prime factor, which is 2 into 2 into 2 into 2, which is 2 raised to 4. So clearly, this is in the form of 2 raised to m. You can say that this is not, there is no 5 raised to n, but there is, okay, which is not visible to you, but I'll make it visible now. Here, I can write on 0, correct? So 2 raised to m into 5 raised to n we are getting, where n is 0 and m is 4, right? So since this is in the form of 2 raised to m into 5 raised to n, where 5 raised to n, n is 0, right? So therefore we can say that this is a terminating decimal expansion. Okay, this is a terminating decimal expansion. Now, suppose you have a fraction, okay, where you are getting something as, just 5 raised to 3. Now, this is again terminating decimal expansion. Why? Because here you cannot see 2, but somewhere 2 is present with a power 0. Okay, so remember that if you're either getting 2 or just 5, it is still terminating decimal expansion. If you are getting anything other than 2 and 5, in the denominator as a prime factor, then it is not going to be terminating decimal expansion. It will become non-terminating decimal expansion. All right. So for example, let us see one example and let us see one non-terminating decimal. Okay. So that example is basically 619 upon 325. So if you have 619 upon 325, if you will take the denominator, if you will do the prime factor of 325, it is basically 5 into 5, 25, and 25 into 13 is going to be 325. Okay. Here you can see that the form is 5 square into 13 raised to nothing, that means 1. But here, this is the problem. Okay. This 13 raised to 1 is the problem, because we know that if we are just getting 2 raised to m into 5 raised to n form, then only we can say that this is a terminating decimal expansion. If we are getting any other thing except 2 raised to m and 5 raised to n, then we can say that this is a non-terminating decimal expansion. So directly you can just find the you have to find the prime factor, okay, of the denominator. You will check whether you are getting that 2 raised to m into 5 raised to n form or not. If you're not getting, directly write down that this is not a terminating decimal expansion. Okay, this is not a terminating decimal expansion. I hope it's clear that if you have, like, now if you'll get any fraction, what you will do, you will just do this step, okay, and you will get it quickly, whether this is a terminating or non-terminating or not a terminating. Okay, I hope that's clear now. Now let us move to a very, very important question, which normally like you get in your board exam paper. So let me write down that for you. So prove that root 3, okay, is irrational. Okay, prove that root 3 is irrational. A very, very important question. Let me write down that also. This is a very, very, very important question. Okay, so if you have not understood how to solve these type of questions, please pay attention here. You will understand it, okay, properly. I'll just make that possible for you. So here, how you can solve this. Before starting the solution, let me tell you one thing, that you may get root 2, you may get root 5, you may get root 7. But the beautiful part here is that you have to use the similar method for all the questions, okay? So if you'll understand for this, you can easily do for root 2, root 5, root 7, root 11, and all the irrational numbers, okay? So let us start with the proof now. So here you have to prove that this root 3 is irrational number, okay? We know what is the definition of irrational. So can we not prove this using some contradiction? Let us prove this using contradiction. So how we can do the contradiction? By taking a opposite, by letting it opposite way. So let us assume that root 3 is irrational. Okay, so we are assuming that it is a rational, and later on you will see that our assumption will be wrong, and when our assumption will be wrong, then our this statement is also wrong. And if this statement is wrong, then what will be the correct statement? Just the opposite of this. That means if root 3 is rational is incorrect, then root 3 is not rational will be correct, and root 3 is not rational is same as root 3 is irrational. So let us understand this. So let us assume that root 3 is rational. And if root 3 is a rational, by definition of rational number, I can write down root 3 in the form of p by q, where of course you know that p and q are integers, q not equal to 0, p and q are co-primes, etc, etc, etc. Now what you will do? Here, what I'm going to do, I'll be writing this as root 3. I'll just do cross multiplication here. So root 3q is equal to p. Okay, I have done cross multiplication here. Now what I'll do, I will just take square on both sides. Okay, so taking square on both sides, this will become 3, this will become q square, and this will become p square. Correct? Now what I'm going to do, I am going to multiply. Okay, I'm going to here, yes, I'm going to multiply here by q on both sides. Okay, so for that, let me write down this as 3 is equal to p square upon q square. All right, I can write down this. Okay, yes, I can write down this as 3 is equal to p square upon q square. Now what I'm going to do, I'm going to multiply by q on both sides. Okay, so this will become 3q, because I'm multiplying by q on both sides, and this will become p square upon q square into q. Now this q with the square will get cancelled, and now what we are getting? We are getting 3q is equal to p upon q, p square upon q. Correct? Yes. Now you can see here that we have on the left hand side 3q, right? So on the left hand side, what do we have? We have 3q. Clearly 3 is an integer, right? And q have taken p upon, like we have taken this root 3 as p upon q, where p and q both were integers. So because q is an integer and 3 is also an integer, so the product is also going to be an integer only. So this is an integer on the left hand side. Now let us check on the right hand side, what do we have, right? So on the right hand side, we have p square, okay, which is an integer. Okay, and we have something in the denominator also, which is q, which is again an integer. But you know that when we have something like integer upon integer, that is nothing but a rational number, right? That is nothing but a rational number. So we know that all the rational numbers are not integers. Okay, we can say the vice versa. We can say that all integers are rational numbers, but all rational numbers are integers, that we cannot say, right? For example, I cannot say that 2 upon 3 is an integer, but 2 upon 3 is a rational number, right? Okay, now you can see here, because all rational numbers cannot be integer, but here we are getting LHS as an integer, but we are getting RHS as a rational number, and we cannot say every time that integer and rational numbers are equal, right? So are we not getting here LHS, which is left hand side, is not equal to right hand side? And because we are not getting LHS is equal to RHS, that means, can we not say that our assumption is wrong? So we can say, since LHS is not equal to RHS, and since our assumption is wrong. Okay, what was our assumption? Our assumption was that root 3 is a rational number, and now we have reached to a conclusion that our assumption is wrong. That means taking root 3 as a rational number, is wrong. So that is why, what is the correct statement? that root 3 is not a rational number, which is same as root 3 is irrational, and hence proved. Now, whatever things I have said in between, if you want, you can also write down those things, okay, as a reason. I have not written the reason, but I have explained it. So if you want to watch the video again, this part, you can rewatch it and you can just write down whatever I was saying. Okay, so I hope this video, like this question was very helpful for you, and you have understood also. So yeah, I'm assuming all of you have understood this question. Now let us do one more question. Okay, one more. So for example, you have proved that. See, when I'll make you understand the concept, I'm going to take few questions also, because if you'll understand the concept and if you won't solve any question, it will be, something like half you have done. So you should do something complete, right? So yes, that is why doing questions as well is also very, very important. So yeah, let's do one question again. So yes, prove that 7 minus 2 root 3 is an irrational number. This question, okay, for example, here you can see that how you can solve this question. For example, root 3, root 5, root 7, root 11, you are going to use the same method. But what about these questions? So this is also very, very simple, okay? Let us understand that. So it is an irrational number. Okay, let me tell you, this is personally my favorite question, okay? Whenever I used to get such type of question that prove that this is an irrational number, I knew how to do this. So yes, that is why I used to love this question. So let us start with the solution. So again, we can say that let us assume that this is a rational number, okay? So let us assume we are going to solve this using contradiction again. So let us assume that 7 minus 2 root 3 is a rational number. Okay, and if it is a rational number, we can write down this is equal to P by Q, where you know about P and Q. I don't need to repeat the same thing, P and Q integers and all. You know that. Okay, now what I'm going to do, I'm going to write down this as 7. I'm going to shift this P by Q to this side. So of course, this will become minus P by Q. I'm going to shift this negative 2 root 3 on the other side. So of course, this will become positive 2 root 3. Let us simplify this, okay? So now what this will become, we'll take LCM 7Q minus P upon Q is equal to 2 upon root 3, right? And this will become, I can also write down this as 7Q minus P upon Q. I can just shift this 2 to this side. So of course, that 2 will come in the denominator. So this will become 2Q equals root 3. Now, can you notice here one thing? That on the left-hand side, you are having 7 cube minus p, which is absolutely an integer. You have 2q in the denominator, which is absolutely an integer. That means, what is this whole together? This is nothing but a rational number. Absolutely, this is a rational number. But can you notice that on the right-hand side, what do you have? On the right-hand side, you have root 3, which now you know that it is not a rational number because you have just proved it, right? You just saw the proof. But RHS is root 3, which is an irrational number, correct? Which is an irrational number, and that we know. And now you can see that we are having on the left hand side rational number, on the right hand side irrational number. So again, we are getting LHS is not equal to RHS. And if LHS is not equal to RHS, that means whatever we had assumed initially was wrong, right? So we can say, therefore, our assumption is wrong, correct? Therefore, our assumption is wrong. And what was our assumption? Our assumption was that 7 minus 2 root 3 is a rational number. So that means the correct statement will be just the opposite of that. Therefore, we can say 7 minus 2 root 3 is an irrational number. Is an irrational number. And hence proved. Nice. And we are done with all the questions, okay, for today. So I hope, I'm expecting that you have understood all the things which I have just explained. So yeah, let us meet again soon in the next video. So I have completed the first chapter of class 10. So if this video was helpful for you, please do let me know in the comment box, because I love to read your comments. I will be excited. I'll be energetic for my next video, of course. So yes, do let me know about that. So I'll meet you soon. Okay. Bye-bye, everyone. So take care.